Today we'll discuss about actuators. Pneumatic actuators are output device that convert energy contained in the compressed air into the motion or a force, either motion or a force. This device makes power and motion available to automated system, machines and process. Let's take example. Using actuator, workpiece or tool can be moved from one position to another, or force can be applied to hold or shape or compress a product using pneumatic actuator. Generally, pneumatic actuator can be categorized into two basic types: linear actuator and rotary actuator. So linear actuator, they convert pneumatic energy into straight line mechanical energy, whereas rotary actuator, they convert pneumatic energy into rotary mechanical energy. Basic function, if we talk about, so the basic linear actuator is a cylinder, as you can see on your screen. An air cylinder is a simple, low cost, easy to install device that is ideal for generating powerful linear movement. Air cylinders are versatile and fast acting, and with the use of special seals they can be withstand ambient temperature even up to 250 degrees centigrades. The theoretical thrust, you can say outstroke wear or pull in stroke of a cylinder, is determined by multiplying the effective area of the piston by the working pressure. F is equal to pi by 4 d square into p by 10 Newton. So as you can calculate inward stroke pull also. These are the equations. Thrust P is equal to pi by 4 d square into p by 10 Newton, d in mm, p in bar. Pull F is equal to pi by 4 d square minus small d square. This is a piston rod diameter into p by 10 Newton. Volumetric flow, if we talk about, or you can say air consumption, cylindrical air consumption. So a cylinder while performing work consumes air, and this air consumption for one cycle of motion of a cylinder is the volume of free air displaced by the cylinder piston during its one cycle of operation. The equation for the volume of free air displaced by the piston during the outstroke and instroke of a double acting cylinder are like V is equal to pi by 4 d square into S into the compression ratio into 10 raised to minus 6, whereas V in stroke, it is pi by 4 bracket d square minus small d square into S into compression ratio into 10 raised to minus 6, where compression ratio stands for gauge pressure plus atmospheric pressure divided by the atmospheric pressure. Then the flow rate of the compressed air passing through a pipe, the relation between the speed of a cylinder piston and the flow rate is explained here, where the piston, if area is a meter square, has moved distance s, this occupies a volume v meter cube of air, where v is equal to a into s, area into the stroke. And if the piston covers a distance s in time t, so it attains a speed small v, where small v is equal to s by t meter per minute. The last equation, Fk is equal to pi square E into I divided by Lk square into S. It is a piston rod buckling. So basically what happens, cylinder capable of giving very long stroke are essential for some applications. That is what we required. So however, if a compressive axial load is to be applied to a piston rod, it must be within the safety limit to prevent rod buckling. So owing to buckling stress, the permissible load of the piston rod having long stroke length is lesser than the ought to have been provided by the same maximum permissible working pressure and the piston surface area. So this load should not go beyond certain maximum value as given by Euler's formula, that is related to the stroke and piston rod diameter, which is Fk is equal to pi square into E into J divided by Lk square into S, where S stands for the factor of safety, or safety factor you can say, which is generally chosen as a 5. Fk stands for permissible buckling force, we'll measure it in Newton. E stands for modulus of elasticity, Newton per mm square, and Lk is equivalent free buckling length, which is nearly 1 to 2 times stroke length. Now we discuss classification of pneumatic actuators in detail. Here shows the basic classification. So this is first one is a linear actuator, and which is subdivided into single acting cylinder, then double acting cylinder. Again, double acting cylinder is having a non cushion type, fixed cushion type, and adjustable cushion type. Then special actuators also available, which are classified as a diaphragm cylinder, magnetic type cylinders, then rodless type, then through piston rod type, then non-rotating piston rod type, bellows actuator, pneumatic muscles. Special assemblies also available, which is a tandem cylinder, multi-position cylinder, impact cylinder, telescopic cylinder, hydropneumatic feed unit, strip feed unit, or rotary indexing table, and the grippers, finger like vacuum, through which we are gripping something or clamping something. And comes a semi-rotary or rotary actuator, which are vane type, then rack and pinion type, and air motor. And the last one is a vacuum equipment. It is a vacuum generator and a suction cups. So we'll discuss one by one. So first is a single acting cylinder, which you can see on your screen. Right, end plate, port, piston, barrel, spring, piston rod, all these are the components of that. And this shows the notation also for a single cylinder, single acting cylinder. And this is classified under the linear actuators. So linear actuators converts the energy of the compressed air into straight line mechanical energy. Technically and economically, pneumatic cylinders are the optimum form of linear actuator. Single acting and double acting cylinders are the two basic type of pneumatic linear actuator. They cover everything from a 2.5 mm bore micro cylinder to a 320 mm bore standard cylinder. I mean to say 0.1 inch to 14 inch. They may also include non-standard cylinders with a bore diameter of up to 500 mm also. And if you talk about single acting cylinder as shown in the figure, this cylinder is a linear actuator with a barrel, piston rod, and end caps, spring, and a single port at the piston side for the passages for the compressed air. This cylinder can produce work only in one direction of motion when the compressed air is applied, and hence the name single acting cylinder. The return stroke of the piston is produced by a built-in spring when the air is interrupted. However, the spring is designed only to carry the piston back with adequate sufficient speed and not to carry any load. In the mostly used sprung-in type design, the spring is provided on the rod side of the single acting cylinder. The stroke length of the single acting cylinder is limited to 100 mm due to the natural length of the spring, you can say. The exhaust air on the piston rod side is vented to the atmosphere through an exhaust hole, which is usually provided with a gauge cover or filter to prevent the entry of foreign particle into the cylinder. The construction and simplicity of operation of the single acting cylinder make them particularly suitable for application such as clamping, cutting operation, ejecting part, pressing parts, feeding, and lifting. For many applications, the return force required are minimal, thus enabling spring return to be used. This minimizes the cylinder air consumption and the required pipe work tube connection in the event of the compressed air failure. Now we'll discuss a double acting cylinder. So this is its little figure with a notation. The construction feature of the double acting cylinder are similar to that of the single acting cylinder. However, there is no return spring provided in a double acting cylinder. Instead, an additional port is provided on the rod side to produce the return stroke when the compressed air is supplied. The piston is extended by the application of the compressed air through the piston side port, with the other side exhausted. The double acting cylinders can perform work in both directions of motion, and hence the name double acting cylinders. And for standard cylinders, bore size range from 8 mm to 320 mm. The force transferred by the piston rod is greater for the forward stroke than that of the return stroke. So double acting cylinder are available in a wide range conforming to ISO and VDMA standard. Then comes fixed cushion cylinder. So first we should understand what is the cushioning. Shock absorption disc. So cylinder end caps have to withstand shock loads at extremes of piston travel. These loads arise not only from fluid pressure but also from kinetic energy of the moving part of the cylinder and load. So when the piston of a normal cylinder is about to complete its stroke, the piston runs into a cylinder end. If inertia is high enough at this point, the cylinder may experience a shock that could be damaging. The end of travel shock loads can be reduced with fixed cushion or valves built into the end cups as per the cushion arrangement. So cylinders are classified into three types according to cushionings: non-cushioned cylinder, fixed cushion cylinder, and adjustable cushion cylinder. So you can see figure which shows you a fixed cushion cylinder. So small bore light duty cylinder have fixed cushion. This cylinder make use of synthetic rubber buffers to give a simple fixed cushion effect. This shock absorbent is placed into the end cover cushion the impact of the pistons. Now you can see adjustable cushion cylinder, in which there is a throttle valve, and there is adjustable cushioning sleeve, and this is the notation. So an adjustable cushion slows down a cylinder's piston movement just before reaching the end of its stroke. Cushions can be applied at one end or both of the cylinder, and this can be adjustable type or non-adjustable type. This cushion consists of a throttle valve and a sleeve attached to the piston. As the piston approaches the end of its travel, the cushion sleeve blocks the normal exit for the air and forces it to pass through the throttle valve, which restricts the flow progressively, retarding the piston movement. The air cushionings are usually designed to function over the final 2 cm of the piston stroke. The cushioning can be adjusted by controlling the throttle valve. In the reverse direction, flow bypasses the throttle valve by means of a check valve within the cushion sills of the cylinder with a very large force and high acceleration. Now we'll see diaphragm cylinder. So you can see in figure there is a piston rod, diaphragm, atmospheric air, and when the compressed air goes inside, and the notation. So a diaphragm cylinder consists of a built-in flat or round pre-tensioned diaphragm, usually made of polyurethylene (PU जो बोलते हैं. So a piston rod is mounted on the diaphragm. In the de-energized state, the piston rod remains in the retracted position due to the resetting force provided by the pre-tensioned diaphragm. When pressure is applied on one side of the flexible diaphragm, it is fully stretched, thus extending the piston rod. Thus a diaphragm cylinder can be regarded as a single acting cylinder due to their functional similarity to the single acting cylinder. As the cylinder move rapidly when the compressed air is applied, and they do not have any end position cushioning, they should only be operated against workpiece. The de-energized and the energized state of flat diaphragm cylinder are shown here in the figure. Now you can see this diaphragm cylinders are used in light duty short stroke, typically 3 mm to 5 mm applications, such as for a rapid clamping of sensitive and slightly uneven parts with small dimensional deviation. The flat diaphragm designs and relatively high clamping force are particularly suitable for clamping elongated workpiece in confined spaces. They can also be used for embossing and lifting operation. Now cylinder with magnetic piston, you can see magnet piston which consists of permanent magnets. You can see here north and south. Then the reed sensors. So in this type of cylinder, a permanent magnet or a permanent magnetic band is provided around the circumference of the piston. The magnetic field of the magnet is used to trigger proximity switches, valves, etc. These proximity switches are usually designed with identical dimension and can be fitted in sensor groove of the cylinder or fastened to an integral rail on the cylinder. Cylinder with magnetic piston, when used in conjunction with magnetic operated switch valves, will provide an electric pneumatic output signals which can be used for many industrial applications. These cylinders have a number of advantages over conventional trip switch, valve switch, etc., providing a compact installation and supporting a neater appearance at a very lower cost. Now we'll see a cylinder with non-rotational guiding. Add-on block cylinder. So you can see here on screen, cylinder with a non-rotational guiding. So non-rotational guiding of piston rod, you can see this guiding is employed for applications where a load attached to the piston rod end needs guidance to maintain precise movement, as in guiding of heavy loads in conveyor system. So guided compact cylinder consists of integrated or add-on twin guide bar running in bearing within the extruded cylinder body. They provide excellent rigidity against the torsion. This shows the mechanical coupled rodless cylinder. Now we'll discuss a rodless cylinder here. So a rodless cylinder consists of a cylinder barrel, a piston and a cartridge, also carriage. The carriage is provided for the purpose of external loading. The piston in the rodless cylinder can move freely in the barrel as in the conventional cylinder when the compressed air is applied. As there is no piston rod in this cylinder, there is no positive external connection or extension. Hence, for power transmission, the piston is to be coupled magnetically or mechanically to a carriage as in a rodless cylinder with Now further you can see a cylinder with a through piston rod. This type of cylinder has a piston rod extending out of the cylinder at both ends, as you can see here in this figure. The double-ended rod provides better rod alignment as the rod is riding between two bearings. So this type of cylinder has equal areas on both sides of the piston and can give equal forces and speeds in both the direction of motion. The cylinder with a through piston rod can be provided with a hollow passages for the purpose of conducting a fluid energy medium like compressed air. A vacuum connection can also be made at one end of center mounted. This page is with the other end fitted with a suction cup. So this type of cylinder is usually center mounted. It can be used when the same type of task is to be performed at either end on staggered cycle, or where one end of the rod is to be used for transmitting force while the other end is to be used for tripping limit switches or some other mechanism. So this is all about a cylinder with a through piston rod. Now you can see bellows actuator. So bellows actuator are durable like single acting actuator. They have no reciprocating parts or sliding seals, and hence they are virtually frictionless, maintenance free units. These actuators are designed with 1, 2 or 3 convolution, which make their installation easy. A bellows actuator is constructed with a flexible fabric reinforced synthetic rubber or polyurethane or neoprene coated polyamide and reinforced with steel cord or aramide. So when the compressed air is applied to a bellows actuator, it inflates and provide powerful short strokes. This movement can be used to lift a load. The bellows actuator must not be pressurized while unrestrained, as it will overextend, and the end plate is likely to be blown free, which could cause serious injuries in the de-energized state. So the bellows actuator is deflated and the loads will fall under gravity. It should be noted that maximum extension and compression of the bellows must be limited by external restraint. When the bellows actuator is exhausted, it must be prevented from crushing by the load. So this is what required to be taken care of. The bellows actuators are designed to function efficiently and economically in the harshest environment. These are available with plastic end plates for lightweight and corrosion resistant application. The versatile air bellows can be used to solve a large number of problems experienced by engineering industry. So standard bellows actuator models are manufactured with a nominal diameter in the range from 8 inches to up to 15 inches with one 2 or 3 convolution and stroke length in the range of 80 to 380 mm. Now we'll talk about the pneumatic muscle. Pneumatic muscle is a type of tensile actuator that mimics or that replicates the natural muscular movement which we have in our body. So basically a pneumatic muscle consists of a tubing that shortens under pressure. In the construction of a pneumatic muscles, flexible tubing which is impervious to fluids is provided with an integrated covering made of strong fibers in rhomboidal form. This results a three-dimensional grid structure, hereby reinforcing the tubing. So generally the maximum tensile force of pneumatic muscles depends on its internal diameter. It can be operated with the compressed air or with incompressible fluids also. The material used for the reinforced tubing are chloroprene and aramide, etc. Chloroprene is a plastic material of the elastomer group. Aramide is a reinforcing fiber made of aromatic polymers. Some terms we should know while we are talking about pneumatic muscle. So first is the nominal length. Nominal length of a muscle is the length of the membrane in the no load and non-pressurized state. Expansion. So the muscle expands when an external force like a free hanging weight is applied. Then a contraction, when the pressure is applied the muscle contracts, that is it shortens and thus develop a pulling force. And the degree of contraction describes the relationship between the nominal length and the extent to which the muscle can be shortened. The smaller the degree of contraction, the longer the service life of the muscle. There are certain characteristics of the pneumatic muscle. It can be operated at temperature ranging from 5 to 60 degrees centigrade and pressure ranging from 0 to 6 bar. The pneumatic muscle reacts to smallest of pressure changes. The maximum permissible elongation of the muscle is about 3% of its nominal length, and the maximum contraction is about 20% of its nominal length. The pneumatic muscle is available for the following nominal diameter like 10, 20 and 40 mm, and corresponding maximum stroke forces at 6 bar are 400, 1200 and 4000 Newton respectively. The advantages are development of up to 10 times higher initial force compared to a conventional piston cylinder with an identical diameter. Second, the highly dynamic operation and high acceleration possible. Third, no stick slip characteristic, as there is no piston using in the muscle. Intermediate positions can be set easily by regulating pressure and having a low cost. There are certain disadvantage also you should know. Double acting function is not possible. Then guidance of load is not possible. Etching of rubber material, it is the biggest challenge with a pneumatic muscle, and the problem of overloading. So apart from this, you should also take care of the safety criteria application that you should know. So generally safety also needs to be taken into consideration when using the pneumatic muscle, right? Muscle under pressure has enormous energy potential. A sudden release of this energy, for example caused by bursting of the reinforced tubing due to incorrect use, can considerably accelerate the attached component of the muscle. Whereas application point of view, the pneumatic muscles being a compact powerful tensile actuator is ideally suited for gripping work. Generally it is used for gripping work, and it finds application where high initial force and high acceleration are required, as in lifting equipment, clamping device, gripping system. And owing to its lightweight and slim design, the muscle is suited for application in aviation, mobile technology, car construction, and highly dynamic devices such as cutting units, simulators and robotics. Now let us talk about tandem cylinder, which you can this figure of which you can see on your screen. So a tandem cylinder, this cylinder consists of two or more cylinders mounted in line with piston connected by a common piston rod. Rod seals are installed between cylinders to permit double acting operation of each cylinder. A tandem cylinder can provide amplified output force as compared to a conventional cylinder of the same bore diameter. In a tandem arrangement, it is possible through end-to-end linking of two or four cylinders of the same diameter and the same stroke length to obtain 2, 3 or 4 times of the thrust of a conventional cylinder. A tandem cylinder is used in a place where a greater force needed to be developed in an actuator of smaller diameter. I am simplifying it. This type of cylinder finds application in place where the diameter of the area in which the cylinder is placed is at a premium but not its axial length. So typical application for the tandem cylinder are found in work holder device and lathe equipment. You can find the application of this tandem cylinder. Now this is a figure of multi-point cylinder. A multi-point cylinder for 3 or 4 positions consists of two separate cylinders of identical diameter which are interconnected back to back by using suitable mounting kit. The piston rod of the one cylinder is the multi-position arrangement is fixed and the piston rod of the second cylinder is used for loading purpose. It is also noted that if one end of the piston rod is fixed into position, the cylinder barrel will then execute the motion. A multi-position operation can be obtained depending on the control method used and the way the strokes are subdivided. A 3-position operation can be achieved by linking together two cylinders of same stroke length, and a 4-position operation can be achieved by linking together two cylinders of different strokes length. So figure illustrate the operation of a 4-position cylinder here. A flexible line must be used for multi-position cylinder connection, and this cylinder has wide application in the machine tool industry where it is used to position material for successive operation. Let us talk about impact cylinder, which you can see on your screen. Pressure and force in pneumatic systems are lower than those in hydraulic system, but by accelerating a cylinder piston to a high velocity and then allowing it to strike a target can generate a large impact force. Such a device is called an impact cylinder. The construction feature and the operating principle of an impact cylinder are extremely simple, inherently offering reliability and long life. Right, pressure is initially applied to, let's say, port B, which you can see here in this figure. So here what we are doing, pressure is initially applied to port B to retract the cylinder. Pressure is then applied to both ports A and B simultaneously. The cylinder remains in the retracted position because area X is less than area A. Area X is less than area A. Port B is then exhausted rapidly using quick exhaust valve. Immediately the full position area X experiences the port A pressure with large volume of gas stored behind the piston, which accelerates rapidly to a high velocity. An impact cylinder can be used as a power unit capable of providing the impact load to an infinite variety of press work applications, conveniently carried out on machinery such as fly presses, kick presses, drop stems, crank presses, etc. In fact, many applications benefit from the impact working, as the high tool velocity and high rate of energy application can produce results such as cleaner edges when cutting and enhanced grain structure when forging. For all impact application, complete guarding must be integrated, either fixed or interlocked with the control circuit. Impact cylinder can develop a stroke velocity of up to 10 meter per second, and depending on the cylinder diameter, impact energy up to 500 newton meter can be attained. This is all about impact cylinder. Now you can see hydro-pneumatic feed unit. It is a hybrid unit, combination of hydraulic and pneumatic. So standard pneumatic cylinder is not suitable for application where uniform working speed is required. This is the biggest challenge with the pneumatic system, where you cannot get uniform working speed. And as in feed application, like when we are feeding tool or something, so feeding application needs a uniform working speed. So but vice versa, a hydraulic cylinder can deliver a uniform speed. Therefore it can be used in combination with a pneumatic cylinder as in hydro-pneumatic feed unit to utilize the advantage of both the types. Right, this hydro pneumatic feed unit, you can see on your screen, it consists of pneumatic cylinder, a hydraulic cushioning cylinder with an integrated throttle check valve, and an air control block to form a compact unit. The pistons of the two cylinders are joined by a cross T, which is shown here, cross T here at last, right side end. Right, the pneumatic cylinder is engaged as the working element, and integrated air control block controls the unit. When the compressed air is applied to the pneumatic cylinder, the piston in the hydraulic cylinder is carried along with it, transferring the oil present in one side of the hydraulic cylinder to the other side of the piston through a throttle valve. The throttle valve can be adjusted for regulating the feed speed. The presence of oil prevents the feed from being uneven when the applied load changes. On the return stroke, the oil can be moved quickly to the other side of the piston through the check valve, and hence the return stroke can be made to travel or traverse quickly. Through a hydrodynamic feed unit, slow and constant feed movement are possible. The speed of the working stroke can be regulated typically between 30 and 6000 millimeter per minute by using the restriction valve of the hydraulic cushioning cylinder. Now you can say pneumatic feed unit. It is consist of gripper, clamping gripper, and a feed gripper. Here you can see the clamping gripper, and here you can see top right, it is a feed gripper here. Single acting cylinders are fitted in the stroke slide and in the base to act as a feed gripper and clamping gripper respectively. By using these grippers, it is possible to clamp and feed rolls, tubes, and profiled material synchronously. So you can see on your screen a very typical pneumatic feed unit. A typical sequence of operation during a cycle in pneumatic feed unit is I'm explaining now. So first, material is loaded through the guides, feed gripper closes, stroke slide advances with the material. When end of stroke is reached, the clamping gripper closes. Feed grippers opens, then stroke slide is returned to the starting position. The machine operation is carried out on the material, and clamping gripper again opens. So the pneumatic feed units can be used for feeding tabs or strips or tools to provide for various machines. The feed speed, feed length, and feed force are infinitely variable. The weight of the feed material can up to 200 mm, and a feed accuracy of 0.02 to 0.05 mm can be achievable. Now on your screen is a rotary indexing table. So in many manufacturing process, it is necessary to carry out feed motion in a circular path. Rotary indexing tables are used for rotary indexing work with a high level of indexing accuracy on automatically assembly and packaging machines, embossing and making equipment and drilling stations. The powering device in rotary indexing table is the pneumatic cylinder used in a conjunction with an air control block, which controls the movement cycle. Now we'll talk about the few grippers. Right, generally two types of gripper we can come across. That is, there are two types of basic types of gripper: finger like gripper and suction gripper. Whereas whatever you see in your figure, so these are some key function of, first we'll discuss some key functions of modern industrial handling system, and many other automatic systems are holding, retaining, and subsequent release of workpiece. These functions can be realized through a technical component known as a gripper. The gripper behaves as a hand in automated machinery. It is like our hand, and by using them, it is possible to easily pick up and move all sort of produced products. They form the link between the workpiece and the manipulating machine concerned. The suitability of a gripper for a given application is depend on its technical properties, workpiece parameter, and environment parameter. The major technological parameters are time available for gripping, the gripping force, the number of workpiece to be gripped simultaneously, and the most important workpiece parameters are mass, shape, surface property, material, strength, and temperature. And the most important environment parameters we should look after are process forces, space available for gripping, dirt, humidity, and vibration. When we talk about a finger-like gripper is made of a double-acting pneumatic drive with finger attached to the cylinder piston through the rake and pinion or lever mechanism. The piston movement makes the finger to open or close. The finger shape is to be tailored or manufactured in such a way as much as possible to the shape and type of surface of the workpiece in order to achieve a large effective area. They are again categorized according to the number of fingers used and according to the way the gripper fingers are moving. So according to the number of fingers, they are classified into following types: 2-point, 3-point, or 4-point grippers. 3-point grippers are the preferred one for handling cylindrical workpiece like a chuck in a lathe. Alright. According to the way of the movement of finger, they are classified as a parallel gripper, radial gripper, and angled gripper, which you can see on your screen. So in parallel gripper, finger moves in parallel across the entire stroke. Likewise, the gripper are usually attached with at least two sensing slots for sensing the jaw position. It is possible to block the gripper exhaust air so that the gripped workpiece is stopped from being dropped from the gripper finger in the event of a compressed air failure. The important characteristics of grippers are low cost, high gripping force per torque, and precise centering. Now we can see the vacuum generator and the symbol. So vacuum devices, vacuum is an absolute pressure below the level of atmospheric pressure. Vacuum generators and suction cups are exceptionally suitable for pneumatic system for picking up small parts made of metal, plastic, or wood. They are extensively used in the industry as an inexpensive component, especially suitable as an automation tools. On handling system, by using this device, it is often possible to ignore a pump for generating a vacuum. So we can generate a vacuum through vacuum pump. A vacuum generator function in accordance with the Venturi principle. This generator produces vacuum in the suction chamber when the compressed air is permitted to flow from, let's say, P to R here. As a result of air expanding through an orifice, a suction cup is the dynamic component that creates the contact between a handling device and the workpiece to be handled. This cup is coupled to the vacuum port U of the vacuum generator. If a workpiece blocks the suction cup, the vacuum produced in the suction cup grips the workpiece. If a pressure of 6 bar is applied, typically a vacuum of 0.8 bar is generated. A silencer is integrated in the housing. So various types of vacuum generator are available, all of which can be equipped with various types of suction cup to obtain the specified values of suction force. The surface of the workpiece has to be clean, and even otherwise the values are reduced depending on the quality of the surface. So within vacuum generator we can find a suction cup, which looks like on your screen. The suction cups can be used to pick up and grip workpiece with smooth and non-porous surfaces by vacuum. When vacuum is present within the suction cup, the workpiece is pressed to the cup by atmospheric pressure. The soft suction cup makes certain that the surface of the workpiece is not damaged. Below suction cups can pick up workpiece with the slightly uneven or curved surface. Suction cups can also be used to grip non-magnetic materials such as glass, ceramics, and wood. The choice of suction cups is very much influenced by the intended application and the associated loads offered by the workpiece and the environment. Important properties required for suction cups are, that is, first, resistance to abrasion, second, oil resistance, then chemical resistance, and short-term and long-term temperature resistance, which are the required or essential properties for a suction cup. Generally, the material for a suction cups are bunion, polyurethane, silicone, natural rubber, white-on rubber, etc. Workpiece temperature can vary from minus 50 degrees centigrade to plus 250 degrees centigrade. In industrial environment, anything above 70 degrees is considered as a special case and usually requires special material. Figure shows a few design of suction cup. They are available in the wide variety of sizes with a nominal diameter from 8 mm to 150 mm. There is a large range of suction cup with flat bellows types in round, square, or oval shape. They are also available in standard extra deep design. Suction cups in the form of bellows allows convex surface to be gripped. application of vacuum equipment, if you talk about, they are extensively used for lifting and handling many types of products and materials, permitting many ways of holding, picking up, transporting and settling down workpiece. And for handling operation, compact vacuum generator with a wide variety of suction cups made of different material and vacuum switches that can be used. The industrial robot is an important handling machine that roughly imitates the human arm with the application of mechanical hand in the form of grippers. Now we'll go for a rotary actuators. So rotary actuators converts energy of the compressed air into the rotary mechanical energy. They are used in all types of applications, particularly where there is a risk of explosion. They are characterized by low installation cost, rapid acceleration, high starting torque. When we talk about air motors, so air motors are designed for continuous rotation greater than 360 degrees centigrade. Semi-rotary actuators are designed for reciprocating rotary motion up to 360 degrees centigrade. 360 degrees, sorry, not centigrade. A rotary actuator can be defined in terms of the torque it produces and its running speed. Starting torque of a rotary actuator is the torque available to move the load from rest. Stall torque is the torque that must be applied by the load to bring a running actuator to rest. Running torque is the torque available at any given speed. Rotary actuators are employed for continuous movement of scrapers or knives in the paper making industry, or as a flame proof drive for mixers and stirrers in process industry. They are used for moving conveyor belt or as a power drive for reciprocating machine tools. Other application includes the operation of liquid pumps and for the movement of an oscillating coolant nozzle on cutting operation. First we discuss a semi-rotary actuator, or you can say swivel, vane type and rack and pinion type, which you can see on your screen. So a semi-rotary actuator is constructed with a rotating vane or with a rack and pinion design. The vane type rotary actuator with limited travel consists of a single vane coupled to the output shaft. This vane type actuator is usually designed for double acting operation with a maximum angle of rotation, let's say 270 degree. Usually the angle of rotation can be adjusted. You can go anything between 0 to 270 degree. The compact rotary actuator is well suited to robotics and material handling applications where there is a limited space. It can also be used as a drive for turning components, operating process control valves, and providing a wrist action in a robotic application. Whereas the rack and pinion type rotary actuator with limited travel, you can see in figure, they are the actuator consist of double acting piston coupled to the output shaft by rack and pinion arrangement. Angle of rotation up to 360 degrees is possible with this type of design. This type of actuator can also be designed for double acting, double torque version. Now this is a sliding vane motor. You can say it is a air motor also. So air motor converts the potential energy of the compressed air into rotary mechanical energy. They are designed to provide continuous rotation. Piston type, vane type and gear design are generally used for air motors. The speed range and the required torque are the major aspect to be considered while selecting air motors. In most cases, air motors are produced in lower HP ranges, horsepower. So typically air motors are available in the power rating ranging from 1 by 8 to 25 HP horsepower. Many speed ranges are possible, ranging from as low as 40 rpm you can achieve up to as high as 50,000 rpm or more. Normally air motors are considerably they are lighter and smaller than electric motors of the comparable horsepower rating. They can be overloaded or stalled without burning out. Air motors start and stop straight away and provide infinitely variable control of torque and speed. They are impervious to explosive atmosphere. Air motors also have disadvantage in including higher initial cost and lower efficiency as compared to electric motor. Application of air motors you can found in powering conveyor belts, printing presses, then screwdrivers, hoist and mixers, and many other type of portable air tools you can find. So there are classified as a piston motor, radial piston motor, axial piston motor, gear motor, turbine motor, and vane motor. So piston type of motor gain their full speed in within a millisecond. It is the advantage of piston motor. Whereas radial piston motor, these motors are available in power rating, having a good power rating up to 1 by 8 to 25 HP you can get. Whereas axial piston motor, so in axial piston motor, 5 or more cylinders are arranged axially, and their reciprocating movement are changed into rotary movement through a swash plate. And it is having a range of 1 by 8 to 3.5 HP, and with speed range 200 rpm to 5000 rpm. Gear motor, so in this type of design, torque is generated by the tooth profile of a two-meshed gear wheel. One of these gear wheel is secured to the motor shaft. So gear motors are available with a very high power rating, or up to 60 HP you can go for. And the gear motor are used to in liquid pump drives, robot arms, mixing drum plates, conveyor drive, belt drive, etc. Turbine motors are used mainly for extreme high speed applications such as starting aircraft jet engines, and for special high speed grinding application involving light load. The turbine motor, perhaps the most sophisticated end motor, has extremely low starting torque for use in high speed application. A dentist might use such motor operating a speed of 50,000 rpm or more for grinding or polishing teeth. You can find the use of turbine motor at the end of dentist. Vane motor, which you can see on screen, the rotary vane motor consists of a cylindrical rotor with sliding vanes placed eccentrically in a cylindrical house. As air enters the inlet port and passes into the cylinder, a pressure unbalance acts on the vanes. This develops a torque that turns the rotor against the motor's load. The vane then ejects the air out of the exhaust port. Rotary vane motors are available in power rating ranging from 1 by 8 to 25 HP, and in speed ranging from 800 to 6000 rpm. The efficiency of rotary vane motors is generally very low, sometimes only 25%. Rotary vane motor generally requires lubricated air for optimum sliding efficiency on the housing. Vane type motors are used in many types of portable tools: power saws, mechanical saws, lifting jacks, controlling motor, driving pumps, driving blowers, and driving conveyors. So it was all about pneumatic motors, or you can say the actuators, in which we have seen the linear actuator and the rotary actuator. Thank you.